Hello students, this is my third time recording this because I recorded the first one as time lapse, and then the second time I realized it was still a time lapse, so yeah, so I guess I have to do a third one now. Okay, so it's just doing up notes for floods. It's gonna be quite simple because I've done this in class a few times with all of you, so just watch lah if you think this helps you in your studying. Okay, so obviously in the center of my A4 paper I'm just gonna write floods, booms. Okay, so that's floods, and firstly we're gonna look at the types of floods. So just gonna extend it to types. Okay, so there are only 3 types of floods. We've learned this many times. The first one is coastal, second one is river, and the last one is flash. Okay, so for coastal flood, all you need to know is that it happens along the coast, and you can see crashing waves. Okay, so you'll see something like that, and then you have your house. Yeah, so for river floods, you're just gonna see the river channel, and you're gonna see both sides of the river. Okay, so that is how you identify that it's a river flood. And lastly, for flash flood, you are going to see built up areas and lots of concrete surfaces. Okay, and because these surfaces are impermeable, it will cause floods to happen as there's no infiltration. So that is all we have for types of floods. Okay, I'm gonna move on to the causes of floods. Okay, so for causes, there are 4 causes of floods. Okay, we are looking at firstly this thing called rainfall, and rainfall is being affected by 3 other factors. So there's the intensity, the duration, and also the frequency. Okay, so intensity just means how heavy it is. Is it a drizzle? Is it a storm? Is it a tropical cyclone? Yeah. Then duration just means how long the rain is lah, like 20 minutes, half an hour, 2 hours. Okay, and frequency just means how often, and there's a probability for this, but we don't really need to know so much about it. Okay, and there's also a formula to calculate rainfall intensity, whereby you take the total amount of rain and you divide by the duration of rainfall. So it is mm over hour. So the units will be mm/h. Yeah. So that is all for rainfall. We're gonna move on to snow melt. Okay, for snow melt, during winter, okay, there will be ice and snow in the mountains. And then during spring, what happens is that ice and snow melts, which then leads to a increase in water in river channels, which will eventually cause floods. Okay, next one, we have storm surge. Okay, so what a storm surge is that there will be a sudden rise of sea level because water is pushed onto coast from heavy rainfall. No, not from heavy rainfall, from storms. Okay, and therefore it creates huge waves. So a simple illustration of what it may look like is that your coast is not a straight line. There's usually curves, right? And then this is the house. So what happens is that there's normally the seawater, but during a storm, the water is being pushed onto the surface, and when it hits here, it rises, okay, forming these storm waves, okay, that will flood onto the coast. Okay, and lastly, we have failure of man-made structures. Okay, so in class we learn about 3 types of structures. Okay, we have our dams, our levees, and our flood walls. Okay, so dam, imagine this is a river over here. So what they do is they build a dam here to stop the river from flowing. Okay, so what happens is when this thing breaks apart and crumbles, the waters will overflow and flood to the land beyond it. Okay, so this is how dam failure causes flood. The other one is levees. So this is the cross section of a river, and the shaded area is the levees. Okay, so levees can hold the water up to this level, and what happens when it fails is that it can topple in or topple out and causes the water to overflow as well. Okay, lastly, we have a flood wall that will look something like this. Say the water is here, so when the flood wall collapses, the water will also overflow and flood onto surrounding land. Okay, so this will be all for types and causes. I'm gonna stop here because okay, we are now looking at the proneness. Okay, why certain cities are more prone to floods compared to other cities. So there are 4 reasons for it, and we are gonna start with, firstly, height of land above sea level. Okay, so height of land above sea level, the sea level that we are looking here is the mean sea level. So if we have a sea, we actually have high tide, okay, I put as HT, and we have low tide, okay, LT. So the average between the 2 heights is what we know as our mean sea level. Okay, so say this line, this area is our mean sea level. If your land is above sea level, you are less prone to floods. But if your height of land is below mean sea level, what happens? It means that you are more prone to floods. So we know countries like Amsterdam, they are actually lower than the mean sea level. However, they are more prone to floods, but they do come up with strategies like having flood walls to prevent the flood walls, which prevent them from getting flooded lah. Now moving on, the second one we have is proximity to water bodies. So water bodies include things like ocean, seas, lakes, rivers, and reservoirs. So if you are living very near, it just means that you are more prone to floods. But if you are living very far, it just means you are less prone to floods. It's as simple as that. Now, the next one that we're gonna look at is permeability of surface cover. And we are just looking at two types of cover: concrete versus vegetated. So concrete, vegetated. Now, just gonna use a thicker marker. So for vegetated surfaces, because they are more permeable, so because they are more permeable, what happens is that there will be more infiltration, which leads to less surface runoff. Hence, it is less prone to floods, right? Now, for concrete surfaces, it is impermeable or less permeable. And what happens is that there will be less infiltration and there will be more surface runoff. Which means that it will be more prone to floods. Now we are going to our last factor, which is channel capacity. Simply put it, channel capacity is how much water your river channel can hold. So I just give you, this is channel A and this is channel B. Now, just by looking at these two river channels, you can see that channel, let's put this as A, this as B. Channel B is deeper and it is also wider, which means it can hold more. Versus channel A, which is less deep and less wide, it actually holds less water. Now, in this situation, if there's going to be heavy rainfall, which channel will be able to hold in more water? Obviously, it's our channel B, which makes it less prone to floods, while the smaller channel will be more prone. And that is all we have for proneness of cities to floods.